Hi, Steve Duffy here again. This is the first in a series of tutorials on getting the most out of the SkyX software. In this tutorial we're going to cover just the basics of the user interface without diving too deep into it, just to get you familiar, and in later tutorials we'll go back through and cover each section in some detail. So the first thing you see when you open SkyX is this sky chart. And it has a lot of information on it. It has the names of stars, constellations, Messier objects, NGC objects. It has the meridian line. It has the ecliptic line, which is the plane of the solar system. It has a target. That red circle is a target where it's pointed right now. The yellow is the place where the telescope is pointed at the moment. When the telescope is pointed at the selected target, then they coincide. Around here you see a green line, circular on this instance, but it doesn't have to be circular. That is the horizon line. You can draw a custom horizon for your location. Inside the circle you see it's darker or it's black. That's the night sky. Outside the circle is grayed to indicate that that's below the horizon. Up here you have a compass arrow to tell you which way the map is pointed. That's important because as you move around, this map sort of takes on a mind of its own. It can get oriented in all kinds of crazy positions, and it's good to know which way it's looking. Astronomical objects rise in the east and set in the west, so they're moving this way across the screen. There's another thing here. This is called mirror image, and it's set this way because this is set for the Robert Ferguson RC telescope, which is a reflecting telescope which in fact flips the image compared to a refractor. So we're seeing it as the telescope would see it. Here we have a zoom bar. You can zoom in and out. If you zoom too much, it'll just jump all the way to the end. So I prefer to use these other zoom tools, which zoom in and out in a more controlled manner. Okay? You also have, on this instance, an item called point to target, which is useful sometimes when you're pointing to something like Pluto, which is a tiny speck in a field of stars. You're not sure exactly where it is, and this puts the target right on, or the laser right on it. You can shut that off by clicking on the little X on the forearm there. So, next thing you see up above the sky chart is what we call the toolbar. And there are lots of toolbars in SkyX. In fact, I will show you kind of a list. All of these toolbars you can put up. But most of them just add clutter, in my opinion. You can open them if you wish. On those toolbars, you have what I would call action buttons. And primarily they're used to change what you see on the sky chart. You can put some other action buttons up there to control the telescope and things like that, but they're not as useful. So I use the toolbar for things that I do a lot. So for example, we want to show the constellation figures and constellation boundaries. We can reduce clutter by turning those constellation figures off, right? And we can turn nebulas off, and we can turn galaxies off, and it just gets less and less complicated. We can even say don't show stars, right? And don't show labels. So you can get it down to be pretty simple. But of course we need most of that information, and when it's zoomed way out like this, it looks very crowded and complex. But if you zoom way in, such as like that, suddenly the labels are not so obnoxious. You might wonder, that's a lot of stars. Can you reduce the number of stars? Yes, you can set a magnitude limit on the number of stars. We'll show that in another video. And you can customize the buttons that you show on the toolbar. So here I am using what's called the small screen toolbar, but I have customized it to put only the buttons that I want to use on it. So we'll show you that also in a later video. Up above the small screens toolbar, you see the menu bar. And this is in a way similar to other programs that you're familiar with. And we will go through these menus in detail later, but you have a file menu, which is basically open and save, but it's not what you might think. You're not opening and saving images so much as you're saving settings profiles, settings for the chart and settings for the equipment. So we'll show you how to do that later. You have the edit drop down, which mostly is used to edit the preferences. There are a lot of preferences you can set in this program, and we'll talk about some of those later. You have the display toolbar, which allows you to display a bunch of different windows. It also has a lot of different things like night vision setup. We don't really use all of these options very often, but we do get into this section, the sky chart windows and the imaging system windows, and we use those quite a bit. The orientation basically is a way to control what the chart looks like, and so you can zoom, you can turn it, you can rotate it. We don't use that very much. It's easier to do it with the mouse generally, although it's sometimes helpful to get it to go back to the right place. The input menu, don't use a lot of that either. One thing though that I'll point out is the location. Normally the location is fixed if you're at Robert Ferguson, but the location is important because the SkyX uses your latitude and longitude to display the sky chart properly. So if you don't input that correct location, you won't get the right sky chart that you're expecting. Over here on the tools list, there are a few things we use here too. The manage observing list we'll go through. Some of these things further down, the image link, the mosaic grid, open fits, the digitized sky survey. You can use all of those things, but there's only half a dozen really from that menu that we use routinely. Telescope. The thing that you might use here is the T-point add-on and maybe the telescope limits. We'll talk about those later. Limits is a pretty simple concept, but the add-on is a program in its own right. We'll have to spend some time on that. And then of course the help menu, which is about what you would expect. SkyX help is the built-in help. It's not very useful. I find it much more useful to go to the SkyX user guide, which is a PDF file that you can search, and the T-point user guide, which you can search. If you ever need to check for updates or get the version number, this is where you find it. So that's the menu bar. Now we have another sort of a menu bar, which is it's called the imaging system windows, and you can see them down the left side here. And these are very important. We use these a lot, and we'll just run through them quickly here. So at the top here we have date and time, and it shows the current date and time, but you see that there's a calendar and there's some buttons to increment the time and some ways to increment it by differing amounts. So The reason this is here is so that you can look out into the future and plan an observing session. So if I know the new moon is coming on the 24th, which this calendar tells me, you see that gray circle? Then I can set to this time and see what's going to happen on the 24th in terms of the sky, and I can even set the time of night and then do a search and see what is up in the sky that might be good to observe. Right now it's set to prohibit all time changes, which is why I got that bong when I clicked on the calendar. But you can go way hundreds of years, thousands of years into the past and future if you want to explore. It's kind of fun sometimes. Okay, next up is the observing list. And what this is a list of objects that are visible now from Robert Ferguson Observatory. And there have been some selection criteria applied. Clearly, you could see thousands and thousands of things, so how did we get it down to only 16? Well, I selected them on the basis of their size. They have to be big enough, both big enough and small enough to fit in the view of the camera. I selected them on the basis of their altitude. They have to be above the horizon. And then I selected them on their type. So I kind of ruled out globular clusters in this list because there's too many, and open clusters there's too many, so I ruled them out because I would get a list of 100 items or so. There's more information in this chart. If you want to scroll across, you can see the right ascension, declination, transit time, rise time, set time, all of those things. And we'll show you how to make one of these observing lists later. But the important thing is if I click on an item here, it gets selected on the chart. You can see that the target moved over there. And if I go to the next window here, the Find window, you see that that NG Seat N25 has been selected in the Find window. And there's a whole bunch of information here about it, telling more about it, more details about its size, location, anything you might want to know about it. The other thing that's useful about this is that we have these buttons that we can take various actions. So I can say, well, I would like to center that object. And you see how the chart jumped around kind of unexpectedly. Now north is that way. That's okay, we don't care too much. If we want it to point north again, I can click on Celestial Sphere and it will point north again. Anyway, I can look at a scanned photo of this object. And so there is a photo. It's not a really good photo, but there is a photo, so I get some idea what it looks like. I see that there are two photos. See the next one, not any better. But I get some idea what it looks like. Some of the photos are pretty good. And now I can do either slew or closed loop slew. Since I'm using a simulator, I'm going to tell it to just slew. We'll talk about the closed loop slew in a moment. So there, you saw that the yellow circle now coincides with the red circle and means the telescope is pointing at that target. Okay? The closed loop slew is a way to get a very accurate pointing. So that the inherent pointing in the telescope usually will get the target onto the camera's field of view, but it won't be centered. If you use a closed loop slew, it does two things. It slews to the target and takes a picture when it gets there. Then it plate solves that picture, and it finds out what coordinates it's exactly pointing at it in the sky. And those coordinates are usually not directly where the target is. So once it has a plate solution, it knows how far off it is from the actual target. It sends a command to the telescope to move a little bit to get that target perfectly centered. And each of those exposures, the first one and the second one, are 10 seconds long, plus 10 seconds or so to download each one. And so when you click Closeloop Slough, it takes about 30 seconds or so for it to finish that operation. At the end, you'll see your target on the screen in a picture, dead center in the picture. But I say that because if you click Closeloop Slough and then you try to slew again before it's finished, you'll put the telescope in a kind of an indeterminate state that's a little bit hard to recover from. So always wait for the second picture to show up. Okay, so now we go over to the telescope tab. Many of you will be familiar with this. There are some drop-down menus here. This is where you connect to the telescope initially. I've already done that. We have star synchronization. So since we've done a closed loop slew and we know that we're pointing perfectly at that NGCN 25, we could sync on that. I'm not going to do it here because I'm using a simulator. But what that does is it shifts the whole sky model that's in the telescope to align with the current pointing. Okay? So it's a little minor correction to the whole sky model that's stored in the telescope. Under Tools, we have Slew to Coordinates, which is a handy thing if you can't find the object that you're looking for in the catalog. So you just type in the coordinates and tell it to slew to those coordinates. And it works pretty well, and you can do a closed loop slew as well. Shut down, we have really all we use here is the park feature. And sometimes this park is grayed out, or it appears to be grayed out, but it still works. Don't ever click the other things here about setting and clearing park position, because it takes a while to get the park position correctly established. You can disconnect the telescope, although you don't need to. Shutting down SkyX will disconnect the telescope automatically. Okay, and you see that the closed loop slew is repeated here. Down below here you see a T-point scatter plot. What that is a map of the errors that we have in the telescope model. So it's a pretty good model right now. It says it's 11.9 arcsecond errors. That is probably not quite true because people have pulled the camera off and put it back on, so it's probably shifted this grouping over here somewhere a little bit. It needs to be rerun, but we'll do that when we finish messing with the camera. Okay, the camera tab itself has drop-down menus: connect, disconnect, and temperature setup. Temperature setup usually is a kind of default. We turn off temperature regulation when the camera is disconnected. One thing I want to say is don't be too quick shutting down the camera. If you just close SkyX, the camera shuts off and everything shuts down, and the residual heat that's in the camera will transfer into the sensor, and it can crack the sensor. So it's best to disconnect the camera and then let it run for 15 minutes before you shut SkyX and before you shut the camera down. Okay? Down here we have 3 tabs: Take Photo, Focus Tools, and Take Series. So Take Photo is for taking a single picture. We'll go through this in some detail in a later episode, but basically you can set the time and take a picture. Focus Tools is really for focusing, and what it does is takes a short exposure continuously so that as you're focusing you can see the focus change. It's got set up for rapid download so that you can see the focus change, because we don't have a live view. This is not a video camera. Then we have Take Series, which is where you can take a whole number of images with different exposures, different filters. You can take light, dark, and bias images. You can set up, I don't know how many columns you can set up across here, but I know I've set up at least a dozen before. This is good for unattended operation, when you're going to run all night and take a whole bunch of series and make a professional grade image. And we'll talk about that in detail later as well. Then we have the filter wheel. Now this is a simulated filter wheel, and so there's a lot of fake filters in there. But the main ones that we would use is RGB, HA, and luminance. Unfortunately, we don't have oxygen or sulfur filters. They would be useful. We do have some other filters for photometry. You might see them in there: B, V, and I. And those are specific filters for measuring the brightness of stars. Gordon Spear will be teaching a class on that. Okay, so the way this works is you just choose the filter that you want. Let's say HA, and say Move Now, and then it will tell you that it's at HA, and then you can go back to the camera window and take a picture with that filter. So there you have the basics of the SkyX window. In the next series, we'll start diving into some of these in a little more detail so that you can get some of your deeper questions answered and figure out how to set this thing to work the way you want it. Bye for now.